Okay, so this would be our second operation on the bulk gauge, and this is really makes up the bulk of this project. You've been checked out on the mill because you've done a minimum cleanup on this edge, and you should have previewed the edge finding demo prior to doing this. And this step is going to be establishing the threaded holes based on the hole locations on the drawing. And to do that, we're going to do a four-step process. Number one is we are going to spot drill the hole on location, and then we're going to drill the hole on location, and then we're going to countersink the hole on location, and the last step is to use the tap and thread the hole on location. So once we've edge fine-tuned this location, I'm not going to move my table. So I know I'm on location here. I can actually make sure that my table is clamped. The first thing I'm going to do is I'm going to use my center drill as a spot drill. And I certainly don't recommend this on the CNC machines, but it's common to use a center drill. A lot of people use a center drill because they're a little bit more familiar with it. And it actually, the tip of the center drill does match, is actually 120 degrees. So it's a good spot drill for a standard drill, even as the center drill is designed really more for a live center. But we are going to use this in soft material, in this case aluminum, to spot the hole for the drill. And spotting is just creating an angle, an included angle that helps the drill stay centered when you start to feed the drill. So I have my RPM set. I think I'm set. I'm going to actually run this at 1600 RPM, but you can calculate that number based on the drill size we're using. In this case, we're drilling into aluminum, so our cutting speed is really high. So we're going to limit that RPM to below 2000 RPM, or not more than 2000 RPM for all of these drills. So I'm in high gear. I have my center drill securely clamped in there using the drill chuck key. And I'm going to bring my quill stop down all the way so I know I have enough clearance. And in this case, I could actually remove this and rotate my quill handle so I'm not in an awkward position when I do the feeding. And when I do this, I can actually bring this down and I can look and see that I'm on location here on my scribe line from my X datum and then from my Y datum on the solid job. And my center drill does center right on the intersection of those two lines. So that's confirming to me that the edge find direction in table travel and the saddle travel is accurate to the layout, which should be accurate to the drawing dimension. It would be pretty rare if you would do an inaccurate layout, and then you would match an inaccurate layout scribe lines to an inaccurate edge finding in both locations. So if you can see that your spot drill matches the intersections of your scribe line, you probably should have a lot of confidence that you had done both of those correctly. The only, maybe the larger mistake that students make on this particular project is their edge finding and maybe even doing the layout based on the sawed edge. You got to make sure datum X is the machined edge and you have this set in the vise oriented correctly based on the drawing, and that your edge finding, your edge finding and your scribe layout matches that was on the drawing based on this Y datum on the solid jaw, and then again your machined edge as the X datum. So this looks good. That's step number one when creating a threaded hole using a tap. I'm going to take this out and I'm going to look at, we'll have set out for you. In this case, I may just give you your own set to use. I have two sets of drills and taps. And the narrow set is the coarse tap. And you can, if you remember through our looking at the tap drill chart, I'm using the tap drill that's based on the tap drill chart, but I'm going to use the Unified National Coarse drill for the coarse tap and the Unified National Fine tap drill for the fine tap. Okay, so in this case, the thicker set, drill set, it's more than twice as wide as the narrow holder for the coarse thread. In this case, I'm going to look at my drawing and make sure I know that in this location it's going to be the coarse thread. So I'm going to not use the fine thread. I'll put this out of my way, and I'm going to check. And the first hole here is 1/4 20, and it shows here number 7 is a 201 thousandths diameter drill. So I'm going to go ahead and take my caliper, and actually I'm going to check this diameter. And the way I measure the diameter on these is I'll try and bring my finger in, and I'll try and measure the entire shank. And in this case, it looks a little small here. So I'm not going to use this one because there is a chance this caliper is not very accurate. So let me get a different caliper. Sometimes the calipers in the school setting get a little bit beat up, and I want to make sure that these repeat. So that's 0, 0. And let's check this one and see. Yeah, that's more accurate. So it actually reads 200 thousandths on this micrometer, but I'm pretty sure the next size down on the tap drill chart is, I guess there's a 199 drill. But I know this is within a thousandths, and I do believe that this is a 201 drill. So I am going to use this drill. This would be step number 2. And I can't get this in there, so I'm going to actually take my table travel in Z and bring my table down. And I'm probably going to need this to bring this down even further, because I know as I continue on, my drills are actually going to get longer. Can you not see that? So I'm going to bring my table down so I have clearance as my quill is all the way up. And then I'm going to, before I use this drill, actually make sure that the cutting edges here are nice and sharp, and my shank here is not too beat up. It's really important that when I chuck on this, I'm going to chuck on this as much of the shank as I can, making sure I'm not chucking on the flutes, and I'm making sure that this is tight. I'm going to use a calculator RPM. In this case, I know I'm above, I think it's close to 5,000 RPM, but I'm not going to run this over 2,000, so I'll have this on. Bring my RPM up a little bit. And I'm going to watch and listen. It's running concentric, it looks good. I don't like how my handle is, so I'm going to rotate this handle. So now and I can peck. I need to make sure a nice chip is coming out of here, so this is something that you'll learn through experience. And then you'll have an idea of your part thickness, and you can feel when it breaks through. So that's pretty good. Once I'm done with that, I'm going to take my drill chuck key here. And then I'm going to, I have a set of countersinks. And in this demo, I'm going to show you a real quick and easy way to establish the correct countersink. All threaded holes, or most threaded holes, should have a countersink, which is a lead for the fastener to start threading into the hole. So I'm going to make sure this is really tight. And if you notice on the drawing, there's a note in the right-hand side of the drawing. It says, it has 4 notes in there. The 4th note is countersink, it's C''sink. All threaded holes, 90 degrees, 10 to 30 thousandths larger than the major diameter on both sides. So on this side, this is what we would call the near side, because it's the side shown in the drawing that we would see in that front view drawing. I'm going to consider the hole, major diameter is 250 thousandths, and it's saying it should be 10 to 30 thousandths larger than the major diameter. So because of that, I'm going to shoot for a 260 thousandths to 280 thousandths diameter countersink. So a very easy way to calculate that. This is a 90-degree countersink. And this, I've drilled a 201 hole, 201 thousandths. I'll just say this is 200 thousandths hole. So with a 90-degree countersink, if I bisect that angle, and it's an even angle, it's a what do you call it? It's not a the length on each side of the triangle, if I bisect it, is even. Meaning, if I want to add anywhere from 60 to 80 thousandths diameter from here, I could actually bring this tool down and bring my quill stop up. And use the push button here. So I actually turn this on, and for this particular tool, I want to go really slow and not be very aggressive. So I'm going to go into low gear. I'm going to go into low gear by pushing this handle in and bringing this out. And in this case, I need to go reverse, so I'm spinning clockwise. We reduce the RPM to around 300 RPM. Now, if I brought this down against the quill stop, I would not be removing any material because it doesn't let my quill go down any further. So in order to get a 260 to 280 thousandths diameter 90-degree countersink, I'm going to zero my table here on my Z-axis. I'm going to set this micrometer dial to 0, And then I'm going to bring my table up half the distance of the difference. So the difference between, let's say, 200 thousandths and 270 thousandths, because 270 thousandths is right in between 260 and 280 thousandths. So 270 thousandths minus 200 thousandths is 70 thousandths. So I'm going to bring my table up 35 thousandths. 10, 20, 35 thousandths. And now I'm going to bring my countersink down. And then I'm going to check this diameter. And it's about 285, so it's a little bit more. There's a little bit of play because it's a single flute end mill, so, or a single flute countersink, so that's pretty good. The other way you can do this is you can actually, you don't have to necessarily calculate using the quill lock and the table feed. You can actually just countersink by hand, trying to get to that diameter, which is 10 to 30 thousandths larger than the major diameter. But this is a more accurate way of doing, even if it takes a little bit longer. So from here, I'm going to remove my countersink. And I'm going to get my tap here. And for the tap, I'm going to make sure this is secure in here. The taps actually should also be checked to make sure there's no damage here on the flutes. Sometimes they get chipped on the cutting edges here. And then you can actually check on the shank. Most of these have it etched in there. It says here quarter 20. NC, in this case it's NC, which is national course. This is accurate. There's another way to check this too, to make sure you're using the correct tapper if you're not sure, because you can always check this diameter here. So I'm checking the major diameter of the tap. Sometimes that's a little harder on some of the there's some 3 flute taps in there. That's hard to check. But in this case, this shows, sometimes they're a little bit larger because the cutting edges of the thread, the cutting edge of the tapper show a little bit larger on the diameter. And then to check the pitch, which is the threads per inch, I can actually use my scale, and I can actually just bring this up to one of the threads. And actually I can just count from the half-inch line. 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, there's 10. So this is a 20 threads per inch. So I just double the number of half-inch, counting half-inch of the threads, or the whole inch. This one should be quarter 20. I'm going to make sure this is really tight, and I'm going to take my let's see, you should see that back there. My lever, I'm in low now because I was doing the countersink. I'm going to bring this out and make sure I'm in neutral so this spins freely. And then I'm going to bring my stop all the way down, make sure I have clearance. Very important, I'm not going to use power, so I'm not going to use the spindle power. I do need to bring my table up just a little bit. And I'm going to use a little bit of oil from the red can. Just a slight bit of oil on my tap. And I'm going to hold, I'm going to bring my quill down. With my right hand, I'll hold this down, and with my left hand, I'm going to rotate the tap until it establishes thread cutting. Now, on the smaller holes, you can see the quill as I rotate, my quill handle will move around as the tap draws into the hole as it cuts. On the smaller hole, I could probably do this entire hole this way, but on the other holes, as I get into larger taps, it's going to be a little harder. So what you're going to have to do when you do the larger holes is, once you have some threads established, maybe at least 3 to 4 turns on your tap, you'll have these tap handles. And I'm going to clamp this little square cutout onto the top of the shank. It has also a square cutout. I'm going to tighten this tap holder here, and I'm going to rotate this using even pressure both ways to finish tapping the through hole. And at some point you're going to feel it very loose, and that's when you know that you have completely tapped the through hole. And then you can back this out, and on the smaller ones you can take it out by hand. So that's the process for tapping a threaded hole. At this point, I've done the 1/4 20. I would actually return over here to my table feed. Check where my table feed is here on my micrometer dial. I know I'm at 312 thousandths. And I would continue on rotating in this table travel to get to the next, making sure, of course, my table locks are off before I start traveling. I would travel to the next dimension, which on my drawing is 781 thousandths. So that looks pretty good. And that's the process we'll be doing in, I think this will be, for most of you, this will be week 2 or week 3. I'll have this posted in week 2. So some of you may be able to get a little bit further ahead. We'll see how quickly we can get done on this particular part of the project.